This is part of Blazor Utils tutorial. In this video, we are going to learn how to fix issues with compare attributes that are present in .NET Core 3 and were introduced in part 37 of Blazor tutorial by Venkat. You can treat this video as a direct continuation of part 50 of the same series. If you followed along the required tutorials, you can skip to the next step. If you didn't, but want to follow along this one, don't worry, just go ahead and open the link from the description of this video and download the entire folder. The easiest way to grab single folder from a GitHub repo is to use browser extension called gitzip. Once we have it, we can simply double-click the blank area of the desired folder, press the download button appearing in the lower right corner of the viewport, wait until Progress Dashboard disappears and save our archive. When we unpack it to the directory of our choice, we can open the solution present in the folder labeled Before. We have to right-click the solution, select Set Startup Projects, and make sure that both API and Blazor apps are set to start during the debugging. Then we need to open blazordemo.api project properties and check that the app URL, including port, matches the one defined in startup.cs of Blazor app. Also, we have to ensure that the browser will be launched at API/employees relative path. Then, let's right-click libman.json file and select Restore Client-Side Libraries to do just that. Now, let's open CreateDB SQL script, replace file paths so they point to the location where we want our database to reside, execute the command and verify that the files actually exist. At this point, we can go back to our solution, create appsettings.json file in our API project and add connection string leading to our database. Since in the brand new DB there is no migrations table, we can safely remove all files from the migrations folder. We also have to open Package Manager console, execute add migration initial create, as well as update database commands and run the project once so the migrations module can initialize our DB. At the end, we have to open Queries SQL script and insert the records present there so the DB remains coherent with what you will see in the next parts of this tutorial. If API project refuses to start with an error, just head to .vs blazordemo config directory, remove application host.config file and restart Visual Studio. This is the same application we were working with during the course of Venkat series. When we try to edit the employee, we can see that there are two problems that are directly associated with the compare attribute. We can experience the first one once we try to change the value of an email. Once we do so, we can see that the compare email is different, but we don't get any validation message. Why is that? Because by default, data annotations attribute fire only for the field that was changed, and not for the other one. The same would hold true even if we had started with an invalid value in the second field. Once we set display name attributes for our properties, the other issue gets revealed. The display names are not respected by the validation. It is actually an issue with all the attributes, but let's focus on a single one. Before we begin fixing things, however, we have to understand one basic concept that allows validation to actually work. Many things in ASP.NET Core exist in context of some other object. Forms, validators, message stores, attributes, and other objects share the same context instances so they can get access to their data and logic. Since these particular contexts operate on a specific model, every object utilizing such context is often able to inherently access the model as well. This concept is called a strategy, and it is part of Gang of 4 behavioral design patterns. According to its specification, objects like forms, validators, etc. serve as clients sharing common strategy like validation or form state manipulation. This strategy is then accessed through the context object and its concrete implementation depends on model and validation scope. The strategy itself is independent from clients using it. Since we got the theory laid out, let's now flip to Visual Studio. First, we are going to add a new class to our common library project that will serve as our compare attribute. We want to make this class public and we want to make it inherit the validation attribute class. Now let's add our other property to it and initialize it from the constructor. Then we have to override method that is responsible for the actual validation. This method is going to use reflection in order to take property info of the property we are comparing against. Also, we want to throw an exception just in case of a null value. Next step is assigning model and other property value to respective variables. Validation should be successful if at least one value wasn't supplied or if both are equal. On the other hand, in the case of a failure, we would like to return a customized error message that takes into account actual display name values of our properties. At this point, however, we don't have getDisplayName method defined just yet. So let's add an appropriate class to our extensions folder. The method itself is straightforward. It uses reflection in order to get value of a DisplayName attribute, or it falls back into a property name. We also have to replace the default compare attribute value for a model, so let's open models folder, edit employee view model, let's find compare property attribute and let's change it to our own. So this is our second issue fixed. We got our own custom compare property attribute and getDisplayName method. To fix the first one, we have to change the logic which is used during the validation. To do so, let's open Pages folder and edit employee Razor page. Validation is triggered during two events. If field changes, then the property associated with that field gets validated. On the other hand, if form gets submitted, then the whole model is validated. So at this point, there are two choices. We can either remove the default validator and implement both events directly in here, or we can create a reusable custom validator control. We are going to use the second approach. To define our custom validator, we have to scroll down a bit, open Components folder and let's add to it a new class and name it Custom Data Annotations Validator. Since the validator itself is a component like any other, it is going to inherit component-based class. We'll start with adding our own initialization logic. Also, we have already said that every single component receives its context, edit context to be precise, in the form of a cascading parameter. So let's make use of it. If edit context cascading parameter hasn't been supplied, we want to throw an exception. Otherwise, we are going to bind the validation events and add methods responsible for the actual validation. Field identifier is a struct that allows to uniquely identify each property. It is created from model and property name. In this case, it comes from the arguments of field change event. We will also need a message store object that will keep track of a validation state and provide access to the messages themselves. Be aware that message store should be initialized only once and then cleared rather than recreated if need arises, to prevent synchronization issues. Let's now focus on a single field validation. We will need model for the field being validated, which can be taken from the field identifier. We will need all property infos for that model that can be retrieved using reflection, and we will also need previous validation state to keep other fields' validation values intact in the future. We are doing this by taking an array of property infos and creating dictionary where property name is the key and collection of messages bound to that property serves as value. Since the validation for every field can be performed multiple times, we also have to clear the message store. Now we are going to iterate over all properties. For each of them, we will need an empty list of validation results that will store an outcome of a future validation, a validation context for our current model and for currently iterated property, and a field identifier for that property. We'll also require an instance of our compare attribute if there is any. Method for retrieving our custom compare attribute instance is straightforward. It takes partial property info matching iCustom attribute provider interface, it finds all custom attributes and gets the one we are interested in by type. Then it performs a safecast to our desired type to ensure that we will get null in case there is no compare attribute for the specified property. In our main field validation method, we need to consider 3 cases for each property. First, the property is the one bound to the field that raised the validation event. Second, compare attribute is not null and its compare to property matches the one that triggered the validation. Third, the property is neither. In first case, every attribute should perform validation. The validation itself is performed by validator helper class that's present in data annotations namespace. The validator class contains method that allows validating single property in the given validation context. The results are then stored in the list passed as the last parameter. The method itself returns a boolean value that indicates whether the validation was successful or not. We want to add a message to our store only in the case of the latter. In the second case, we want to restore all previous messages that weren't a direct result of applying compare attribute in the same context. To do so, we are utilizing the getErrorMessage method we have defined in our compare attribute and comparing its outcome with all other messages. After filling the message store with previous data, we have to perform the validation with our custom attribute only and add another message to our store if that validation failed. To perform the validation, we are using tryValidateValue method, which allows us to specify an array of validation attributes in addition to the context. Third case is even easier to implement. All it requires is restoring the previous messages that are stored in the dictionary. The last thing left to do is notifying the edit context that the validation state has changed. Model validation is even more straightforward. We are checking all properties in the given context and then capturing all the invalid messages and adding them to the store. At the end, we are raising validation state change event. We also have to replace our default validator with the custom one that we have just created inside editEmployee.razor file. Now, let's press F5 and start debugging in order to verify that everything works correctly. We can notice that regardless which email we are going to change, the validation now works without issues. Also, the display name attribute values are respected. That's exactly what we wanted. Let's now try to submit this form, but first, let's remove first name just to get the validation for that field, and let's press submit button. As we can see, the validation now is not performing correctly. To find the reason for this issue, we have to actually go back to our custom compare attribute implementation. Validation result that's returned from isValid method has one more overload. It allows us to provide member names. Member names are essentially properties. If we decide to omit this attribute, we will have a validation message that's associated with a model in general and not with a particular property. Once we stop at the breakpoint place in our custom validator while submitting the form visible previously, we can clearly see that since we didn't provide a member name, we have nothing to iterate over. So despite the fact that the validation results include our compare attribute message, it won't be added to our store. To fix this issue, we are going to supply a member name as the last parameter of a validation result in our custom attribute. Also, since validation result allows to omit member name, it is a good practice to reflect that fact in our model validation logic. Now we can perform one more test. We can clearly see that everything works exactly as we wanted. Additional content as well as code samples can be found in the description of this video. I hope you've enjoyed my first tutorial. Thank you for listening.